Hello everyone, welcome to Minds of Aspirants channel. We are doing a series of video where the conceptual clarity lessons are being taken. Okay, the first class I have took on El Nino and La Nina. For those who haven't watched it, please do watch it. It will be a simple explanation about the El Nino and La Nina condition. Okay, in this video we will be seeing tropical cyclone. Okay, so let's get into the video. Now, please pause this video and try to define the word cyclone yourself. Okay, so hope you have came up with the three keywords. Let's see what is the actual definition of a cyclone. Okay, now this is the definition. That is, it will have a rotating storm, right? A rapidly rotating storm. Rotating means that's why it's created a cycle, right? So that's why it is called as a cyclone. So in cyclone, a rotary motion should be there. Okay, that's the point. A tropical cyclone is a rapidly rotating storm system characterized by a low pressure. Okay, so here is the second keyword. Okay, it should have a low pressure center. Okay, then it where this will happening, it will be happening in the lower level in the atmospheric circulation. Okay, it will happen in lower level atmospheric circulation. Okay, resulting to this, a strong wind will be generated. Okay, and a spiral arrangement of thunderstorms will be happen, resulting in the production of precipitation or heavy rain. Okay, this definition should be in a simple manner. It can be on your own words too. Okay, fine, let's get into the next slide. So for the better understanding, I will be going into the concept in a step-by-step manner, where 3 to 4 concepts I will be teaching you. Okay, the 3 to 4 concepts is are very simple in nature, and you have already studied in your lower standards. Okay, now the first concept we are going to see about the pressure system. Okay, this is the very old concept. We already knew this. Okay, but still it will be very helpful if we learn it here again. Okay, this air is expands when heated. Okay, air gets expand when it gets heated. Fine, and when it gets cools down, it will be compressed. Okay, when air gets heated, the air will expand, right? And when cools down, it will be get compressed. Okay, this is the first concept. Okay, now because when air gets heated, the particle in the atmosphere will get expanded, will move away from one another. Okay, that is the concept here. So this reverse vice versa will happen in compression, that is cooling down. Right. The second point is, there is a difference between air and wind, right? So air is different, wind is different. So how this correlation is, the movement of air particles will be denoted as wind. We can feel air anywhere. Air will be present in anywhere, but wind is a movement when the air particles move from point A towards point B. This movement is called as a wind. Basically, this movement will be representing high pressure to low pressure. Okay, obviously high pressure means more air particle will be present here, and low pressure means no air particle will be present here. So obviously the particles which are higher will be moving towards the lower end. Fine, so this is the concept behind it. And the vertical, this point we obviously know, right? So the vertical rising of the moist air forms cloud and bring precipitation. Okay, so this concept here denotes the form of a condensation process. Okay, hope you have understood this. But still, for the betterment of the clarity, this is the low pressure condition where the temperature will get increased due to the presence of sun, and the moist air will rise. Okay, the resulting in the formation of huge clouds. Okay, resulting in the formation of huge clouds. Fine. So in the process of condensation, what happens, the gas particle will then be converted into the liquid particle, right? Okay, so when this threshold breaks, it will be come down as precipitation, and in our case it will be have a rainfall. Fine. So this is the condition on low pressure. What happens in the high pressure? The vice versa will happen. That is, the movement of air particle from above, it will get subside. Subsidence of the air mass happens in high pressure. Okay, subsidence of the air mass happens in high pressure. Imagine the all air particles will be coming into your head, so you will feel pressure, right? So that is what here. Subsidence of the air mass creates high pressure. Fine. Okay. This is the second concept. Normally, just before I have said, high pressure means more number of air particles present in a particular point. Imagine you have been placed in a 100 square feet room with 100 people. So imagine the pressure there. You will be willing to come out at any point of time. So imagine you have been released with the all four walls open. So all people will be going in each and every direction available, right? So same in the case of you can take balloon. In balloon, the more pressure will be inside the balloon, and the nozzle is open, the movement of air particles will be moving from inside to outside. So that means the balloon inside will be having high pressure, and surrounding the region will be having the low pressure. So the basic concept is, when the high pressure is there, there will be having a divergent force. Okay, divergence will occur. When high pressure is there, divergence will occur, and vice versa will happen at low pressure. Many people will tend to come to the place where no one is there. When vacuum is there, air particle will tend to move towards the low pressure region, where they will tend to fill that particular gap. They will tend to fill this particular vacuum present. Okay, so in low pressure condition, convergence occurs. Okay, so you have to remember this concept very, very clearly. So divergence happens at high pressure and convergence happens at low pressure. Okay, fine. Third concept is very simple, that is, we are seeing for evaporation and condensation. Don't need to see these. Just in evaporation, what happens is liquid is converted into gas. In this process, heat is absorbed. That is, when liquid is converted into gas particle, the heat present in the atmosphere, what happens is, this will absorb the heat. Okay, it will absorb the heat and it will be hidden in the particles, which is called as latent heat. It will call as latent heat, that is hidden heat. Okay, so when the process of evaporation occurs, do remember that heat is absorbed here. Okay, heat is absorbed here. And obviously the reverse will be condensation, where the gas will be converted into liquid. Here the process will be reversed, where the heat will be released. Heat will be released here. So the hidden heat present here will be released when the gas is converted in the form of liquid. So in evaporation, heat will be absorbed. In condensation, heat will be released. So this is the third concept. And the last and final concept of this class is Coriolis force. Okay, the Coriolis force is the one that is an invisible force. Okay, that is an invisible force that appears to deflect the wind. Okay, it will appear to deflect the wind. And how this Coriolis force produced is, it is due to the movement of our Earth's rotation. Okay, our Earth's rotation process happens, right? So Earth will be rotating from this direction to this direction. Okay, in this rotation force, this Coriolis force is generated. And for the people, those who have copied this formula, please strike out this. You no need to take down this formula. Just you should know that a rotary movement creates a Coriolis force. Rotary movement of the Earth creates the Coriolis force. Please do not research in this topic. Okay, so when and where this and how this Coriolis force work, in what direction the wind get deflected, we will see in the next slide. Okay, wind is deflected. Okay, we are going to see how this and where this wind get deflected. So this is the diagram you should remember. Okay, you all know this is the equator, and this is North Pole here, and this is South Pole. Okay, When you travel from equator to north, you will be deflected to right side. Okay, and similarly in the opposite direction, when you travel from equator to the south pole, you will be deflected towards left side. Okay, you have to remember this carefully. Okay, so when you travel in northern hemisphere, when you travel from equator to north pole, you will be deflected towards right, and you will, when you travel in the southern hemisphere from equator towards south pole, you will be deflected towards left. Okay, and at a given point, if you're traveling from north pole to equator, again you will be deflected towards right. To remember this, imagine, in the sense, not imagine, we are present in India, right? So India is in northern hemisphere, right? So we are always right. We are always right. So we should deflect in right side, irrespective of when you are traveling from a north pole to equator or equator to north pole. In northern hemisphere, wind will be deflected towards right hand side. Okay, and similarly in southern hemisphere, wind will be deflected to left hand side. Do remember this, it will make a life more better. Fine. And this can be seen in the planetary winds. Okay, in planetary winds, see, when you're traveling from north to south in northern hemisphere, deflected right side, and similarly this left side. Okay, this is the planetary wind. I will be taking class from the planetary winds in coming days separately. Okay, so as far as now, this slide is for just to make you clear that it is an example for the Coriolis force. Okay, the wind gets deflected right side towards right side in northern hemisphere and left side in southern hemisphere. Clear? Okay, now let's put these concept one together. Okay, one by one we can have this concept. So imagine you are having low pressure here. So in low pressure, what happens? Convergence should happen, right? So no one is present here, only vacuum is there. So to fill this vacuum, 4 people, A, B, C and D, 4 people are coming towards the center, that is to fill the vacuum, and they are present in northern hemisphere. Okay, so when in this process, since they are present in the northern hemisphere, they should deflect towards the right side. They should deflect towards the right side, right? And our 4 people will be get deflected. Okay, so imagine when many people will be coming, so all will be deflected towards the right side, right? So this movement will create, if you see, this movement of particles will create a movement in anti-clockwise direction. Okay, this movement will create an anti-clockwise direction. Okay, so what happens is, when there is a low pressure center in northern hemisphere, it will result in a anticyclonic condition, sorry, anti-clockwise direction. Okay, anti-clockwise direction. Fine. Okay, being said that, just I want to ask you some questions. Why are there is no tropical cyclone present at the equator? Pause the video. Okay, pause the video and try to imagine and try to guess the answer. Okay, fine. Now let's see why there is no tropical cyclone in equator. We have seen that the Coriolis force is one of the most major driving factor, because when the Coriolis force is absent, the wind won't be able to deflect in the right side or left side in the northern and southern hemisphere respectively, right? So in order to get the cyclone emerged, Coriolis force is one of the most important factor, right? When the Coriolis force is not present, obviously there won't be any cyclone, there won't be any deflection of wind. Fine. So and resulting in there will be no cyclone. And in equator region, what happens is Coriolis force is nil. Coriolis force won't be there in equator. So therefore we cannot able to see cyclones, tropical cyclones in equator. Okay, in general, what happens is the Coriolis force is directly proportional to the angle of latitude. That is, when you move from equator, when you are moving from equator to poles, the greater you tend to move towards the higher latitude, the more you get deflected. Okay, the Coriolis force is directly proportional to the angle of latitudes. Fine, and it is very maximum in the poles, in north and southern poles, and it will be zero in equator. It will absent in equator. Fine. Okay. Now let's see the pattern of wind direction. We have already seen that cyclone will be moving in anti-clockwise direction in northern hemisphere, right? So if you are able to get this concept correct, okay, cyclone will have low pressure at the center, right? Cyclone will have low pressure at the center, and in northern hemisphere it will be moving in anti-clockwise direction. The opposite will be in the southern hemisphere. Okay, it will move in clockwise direction. Fine. What about in anticyclonic condition? Anticyclonic condition, this pressure center will be the high pressure. Okay, high pressure divergence will happen. Okay, just make it as an opposite. Okay, in high pressure divergence will happen, and in northern hemisphere it will be moving in clockwise direction, whereas in southern hemisphere it will be moving in anti-clockwise direction. To make it simple, I will tell you as cyclone anti-clockwise northern hemisphere. Remember this word. Okay, cyclone anti-clockwise northern hemisphere. Fine, do remember this, and you will be able to crack the question in 4 different ways, whichever the way they ask. Okay, now we have named this topic as tropical cyclone, right? So it should fall in this category only. Okay, so this is the tropics, right? This is tropic of Cancer and this is tropic of Capricorn. Okay, so imagine if a cyclone happens here. Okay, imagine a cyclone happens here, and you already know that the movement of trade winds, right? The movement of trade winds, you know it very well. It will come in, it will converge in the direction of equator. Okay, so imagine if a cyclone occurs here, what happens? I mean, in the sense, no cyclone will occur in equator since there is a no Coriolis force. And what happens is that if a cyclone occurs here, it will hit the which margin? It will hit the eastern margins. It will hit the eastern margins of the continent. So if a cyclone here, it will hit in the eastern margin. If a cyclone occurs here, it will hit in the eastern side. Here, it will hit in eastern side. So in tropical cyclonic condition, due to the presence of trade wind, when a cyclone occurs, it should hit in the eastern side of the continent. Fine. And similarly, it will be opposite in the case of westerlies. In temperate cyclone, the westerlies wind will be flowing in this direction, and if the cyclone occurs here, it will tend to move in the direction of westerlies. So it will tend to hit the western region of the continent. Okay, in simple words, tropical cyclone, okay, tropical cyclone will be affected by easterlies, will be hitting the target on eastern margins, eastern landmass. Okay, for temperate cyclone, it will be affected by westerlies and it will affect the western margins. As simple as that. Okay, now let's see the few conditions on what basis the cyclone will be formed. Okay, first of all, we should have a very high temperature. Now, normally it's, now some people will say 26.5 degrees Celsius, but 27 will do. Okay, so 27 degree temperature should be there, and obviously Coriolis force is the one of the main determinant factor for formation of the cyclone we have just now saw, and low pressure should be occur. And there are some more few points where I will be explaining you one by one. Fine. So this is the condition where the one of the most predominant condition is the ocean water will be get warmed intensively. Incoming insulation should be very high, that it can reaches to the temperature of 27 degrees Celsius, so that the huge amount of water gets heated over a period of time. Okay, so what happens when the water gets heated? What happens? The first point in this class, when air gets heated, it will expand, right? It will expand, which results in rising. Fine. So this will happen. Okay, so this air will tend to, the moist air will tend to rise. Fine. So when this happening, the low pressure will be created. A mild low pressure will be created. Fine. So due to this creation of this low pressure, wind surrounding this regions will try to occupy this low pressure region. Okay, so we are having two forces: the force where the air tends to move upwards, and the vertical movement of wind and the horizontal movement of wind. Fine. Now what happens is the moist air, okay, the moist air, before in this slide, the process of evaporation happens here, right, where the liquid will be converted into gaseous state. So what happened here? Heat will be absorbed. Okay, heat will be absorbed from the surrounding region and it will be hidden in the gas particle. Okay, it is called as a latent heat. Latent means hidden. It will be hidden in the gas particle and it will tend to rise. Okay, after rising, what happens? Condensation takes place. Condensation takes place. In the process of condensation, gas will be converted into liquid, right? Gas will be converted into liquid, and here what happens is the the latent heat which was absorbed in the evaporation process will be released, here. Okay, so what happens is when condensation occurs, heat will be released in this region. So what happens when the heat is released here? This area will be getting warm. And what happens when we get warm? The air again tend to rise, right? So what happen? A low pressure inside the low pressure will happen. This intensifies. The more amount of air being sucked into this pattern. Fine. So the more amount of air gets intaked by this pattern and resulting in the intensification of this cyclone. Okay, this more amount of water will be moist air will be more amount of moist air will be getting into this process. Right. Now this will happen in a cyclic way. Okay, and with this a Coriolis force will also act. See, all this happens in an overall logical plan. It won't be happening in step by step process. This will happen in a correlation to each other, that this will happen in a overall concept, and overall concept what we have studied we will be applying one by one. Okay, so this is the mature stage of the tropical cyclone, where you can see the formation of eye. Okay, the low pressure center will be more intensified, that it won't get be eradicated unless it reaches to the one particular point where it get dispatched. In this concept, a spiral wind will be created in this direction, where a cyclic pattern will be emerged. Okay, this is the first point where the warm moist air moves over the ocean. Okay, so where the liquid will be changed into gaseous state. In this, heat will be absorbed. And the next point is that water vapor rises into the atmosphere, right? Water vapor rises in atmosphere. Then the third, what happens is the condensation process occurs. In condensation process, heat will be released, right? So when this region gets warm, it will again, the air will again get raised, and the more amount of air mass will be get intensified in this process. Okay, the warmer air continues to rise in the moist air from the ocean, taking place in the created more wind. The more wind will be coming into the act. Okay, so this process moves continuously, and when the cyclone gets disrupted, see, the major driving force here is the moisture. Okay, the major driving force of the cyclone is moisture. When the moisture is cut off, when we stop the moisture supply to the cyclone, we can able to end the cycle of the cyclone. Okay, so we have to cut the supply of moisture when the possibility is that when the cyclone reaches the land, the moisture supply will be cut off. Okay, you can see this in the GIF where a cyclone moves intensify in the oceanic region, but it will get a slower, it will get dissipated. It will get dissipated when it reaches to the landslide. You can see here, and to show it clearly, and you can see here, it will be very intensified in the ocean, but the moment when it reaches to the land, it get dissipated. Right. So this is how a mature cyclone get dissipated when it reaches to the land. Okay. So obviously we have seen that it will be hitting to the eastern side, right? And why this direction happens is, you know that the Tropic of Cancer happens to be this line, and these are the trade winds. This cyclone, when comes in this region, it will tend to get in the influences of the westerlies. So that's why the direction of cyclone have been in this direction. Okay, so in the local names will be the typhoons in Japan and South China Sea, and hurricanes in USA and Canada, and cyclone we what we call it here, and willy will be called in Australia. Okay, these are the local names of cyclone which can be asked in MCQs. Fine. Now, and the last point is the how these cyclones are named. See, basically there are some 6 organizations around the world which also includes the Indian Meteorological Department for the commissioning of the naming of cyclone. In 2000, what happens? This group of nations around the Indian Ocean region, these countries came up and decided to name the cyclones on their own. In a way such that it won't affect any religion or ethnic sentiments, and thereby it should be very simple and easy to pronounce. Okay, these are the countries came forward and came up with this idea. Okay, later in 2018, these 5 countries were added. And remember, in geography, when you're reading such facts, please do read with maps. Okay, now let's see. So we are going to name the cyclone in the Indian Ocean region, which also includes Arabian Sea and Bay of Bengal. Okay, so here what happens is, obviously India will be there. That's the only ocean which will be named after any country, so India will be there, and all the neighbors in India which are connected to the seas will be the part of this project. See, our neighbors, Pakistan will be there, Sri Lanka, the original members, Pakistan, Sri Lanka, Bangladesh, Myanmar, okay, and Thailand and Maldives. So when Myanmar comes, Maldives also will come. Okay, so Thailand is also there. So Bangladesh, India, Maldives, Myanmar, Pakistan, Sri Lanka, and Thailand. Okay, so when these countries are naming, a man comes, Oman, join me also. Fine. So Oman is also one of the country. Oman is one of the front runner, and in the sense these are the original countries. Okay, in 2000 they have started naming. Okay, what happens is, when the Oman comes and they started naming the cyclones, the neighbors of Oman, please, they have been shouting like, we are also coming. So what happens is, in 2018, Iran, Qatar, Saudi Arabia, UAE, and Yemen also came. So all these are neighbors of Oman. So this is how you can able to connect the flags. So India will be there, Pakistan, Bangladesh, Sri Lanka, Myanmar and Maldives, Thailand and Oman will be the original countries, and later it will be added by Iran, Qatar, Saudi Arabia, UAE and Yemen. Fine. So hope this video makes you a little bit more concept clarity, and please let me know the topics which you are in need of, so that I can make in a simple and clarity way. Okay, do share this video with your friends, and if you have any doubts, please comment below, so that I will be personally replying to that comment. Okay, thank you for watching this video. Have a good day.